Hi, welcome to this module, Introduction to Data Science in Julia. So this module is part of the course Intro to ML in Julia. And currently what we are trying to learn is how to implement data science basics within Julia. In this lecture specifically, let's look at two of the most important things that anyone should know how to do, which is data preprocessing and cleaning. So this lecture is divided into 5 parts. First, we will talk a little bit about data cleaning itself. What exactly does that mean? And then we'll be writing code from scratch on how to, for example, handle missing values if you have a data set, how to transform the data by maybe renaming your data set, some features of your data set, or how to add new features, or how to even perform something called as feature scaling, which is often done in machine learning models. In ML, if you have huge discrepancy in the magnitude of features, let's say you have 2 dimensions and one of the dimension has extremely high magnitude, then it results in poor machine learning model learning. So you have to scale the features, which is typically done so that sometimes the feature is a range of values centered around 0 and between +1 and -1, for example. So there are different ways to scale features. We'll be talking about one of them in this lecture. So I'll be coding completely from scratch slowly so that you can also follow along with me. I'll also show you how to open the Jupyter notebook again, just like how I have been showing in some of the past lectures as well. Assuming you have Julia installed on your computer and assuming you have Jupyter notebook installed on your computer. If you don't have them installed, just go ahead and Google Julia installation. You will find the instructions is very, very easy. It won't take you more than 5 minutes to do both of these. So in data cleaning, some of the most common issues that I have encountered while working on research projects with respect to ML is missing values. So some of the rows. So if data set is like a table in some format, and let's say each column is a feature. Let's say it's about health data set, and each row is a person. So this is person 1, person 2, etc. And this could be BMI, age, cholesterol level, etc., different features. Then sometimes some of the cells will have missing values. This is very likely. And this is how real world data is, right? Because you may have information about a lot of people, but sometimes some information about some people will be missing. So this missing value is a very, very common issue. The second thing is sometimes you can have duplicate rows or records. This also I encountered very recently when we were working on a research project. So we were trying to train a natural language processing module, how to detect between AI produced and human produced text. And one of the issues that we encountered in the initial data set that we had, which we downloaded from Hugging Face, is that many rows were repeating. Then what happened was when you split the data set into training data and testing data, some of the rows or some of the data points that is there in the training data occurs exactly like that in the testing data also. So this was giving a false sense of good test accuracy. In reality, if the data was not duplicating in both training and testing, the accuracy would not have been that good. But because in the entire data set there were duplicate records, this was causing the accuracy to be falsely high. So this is the second issue. Third issue is outliers. So sometimes some extreme values may occur in the data set which may distort the result. An example of that is for let's say you have the height as one of the features. Let's say this is the height of the person. And everyone's height may be, let's say, 175 centimeter, 160 centimeter, etc. But suddenly you have the height of a person who is like in feet. So it's like, let's say 5.5 feet. It's in feet and inches, but let's say it's 5.5 feet. So now this can cause an issue in training because the units of this particular data point is different. The value, the number associated with that is very different from the rest of the value. So this is an outlier. So the data set can have a distribution, right? Centered around a mean, but then there could be outliers which are far away to the right or far away to the left, meaning it can be much lower than the mean or it can be much higher than the mean. These are extreme values which may distort your overall performance of the ML model or distort your entire result itself. So you have to take care of this. So these are some of the common issues you encounter in raw data set, which you have to clean. often some of the data sets that you will encounter when you download them from, let's say, Kaggle or Hugging Face will be clean data. But in reality, when you are working on an industry level machine learning project, you will not have clean data. You have to clean it yourself. You have to figure out the issues with the data. We will learn some of that with a sample code in today's lecture. So let us first open Julia. So what we do is we open terminal. So type terminal here. I'm working in MacBook, but if you're working on Windows, you can open the command line. And then here I'm opening a new terminal just to show you how to do this. And I can increase the font size. And here, what I usually do is like I type Jupyter Notebook, and I have installed Julia for Jupyter Notebook as well. So just run this and then it should open the Jupyter Notebook. I'm not going to run this right now because I have Jupyter Notebook already open. So when we have Jupyter Notebook, it shows something like this. And here you can open something called as Jupyter Lab. So click on View, click Open Jupyter Lab. So that should open the Jupyter Lab. Now here we can define the kernel. We need Julia kernel. So instead of Python, so here I have installed Julia for Jupyter, which is why along with Python, you also have Julia. But if you have not installed Julia for Python, you will not see this. This we have covered in detail in the second lecture of this course. So please check that out. Now let's run some initial set of codes. So I will rename this as maybe part 1. This is not an IPy notebook. This is a Julia notebook, right? So .jl actually. So here we can define this to be like a markdown file. So define the data set. So what I did here is I selected markdown, and then we can run this so that this become like a text. And then let's define. So this is now a code. So here we need to using data frames df equal to data frame of. Now we have to define certain data points here. So let's say our data set has 3 features. One is ID of a person. Second is name. Third is age. And fourth is income. And here ID, let's say there are 6 people. ID is 1, 2, 3, 4, 5, 6. Then name is, we can define names of 6 people. Aaron, Brian, Thomas, Katie, Julia, and we need 6 people, right? So, and 6th one could be Catherine. Then age, I'll put some random ages, 28, 40, 57, 22, then 33, 34, and 44. Income, let's say the first person has an income of $60,000 per year. I'm mentioning in dollars, not in rupees. Second person has 70,000, let's say $85,000 because that person is a bit older. Third person has $120,000. This person has $65,000. This person has $79,000. And finally, last person has $82,000. Some random numbers. Okay, so now let us run this to create the data frame. Hopefully this should work without any error. Okay, so define the data set. And we are defining the data set and the data frame, right? So we did that. There is some error. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. I guess I need to put either semicolon or comma here. Let's figure out. Comma is missing. Okay, how about now? It should hopefully work. It's just taking few seconds to run, but yeah, finally we have the data frame. So it's a 6x4 data set. Why? Because there are 6 rows. Each row is corresponding to a person, and there are 4 columns: ID, name, age, and income. So this is the data frame. Now, sometimes some values in this can be missing. So, for example, let's say df2 equal to data frame where this name is missing. So if it is missing, instead of keeping it empty, we write missing like this. Let's say this person's income is missing, and maybe the first person's age is missing. Some values are missing throughout. Then we can run this, and this will also create a data frame which resembles a real life data set where some values are actually missing. So here the name of the person is missing, here age is missing, here income is missing, right? So three rows have empty features. Now let's see how to handle this. Before changing anything in the dataset, I also want to show you a couple more things. Sometimes the dataset can have duplicates, right? We had mentioned that. So here I'm creating a new data frame called df3, where let's say we have one more person with this ID 6, and which means the data corresponding to Catherine is having a duplicate. So age 44, this is a duplicate, and this is a duplicate. So now when we run this, you can see that the 6th and 7th rows are exactly same. They are duplicates of each other. Now let's take one more data frame in which you have an outlier. So what could be an outlier? An outlier could be something like, let's say, now you don't have the duplicate, but you can have an outlier. So an outlier would be something where, let's say, the age of someone in the data set is suddenly 1000. Nobody is having 1000 years of age, right? But this is an example of an outlier. This data set has some issue where the name of Katie, corresponding to name of Katie, the age is 1000 years. Now there can be another data set where all these issues can be there at once. So I'm going to copy paste this. Let's say I'll copy paste this. So here two of them are repeating. Now let's say the age of this person is very big and some items are missing. So ID here is missing. Here this is missing. Now if we run this data frame has 3 issues. There are missing elements. These features are missing. There are duplicate rows, and there is also an outlier. So these are typical, although we created this data set, these are very typically occurring issues in data sets, right? So now I will rename this part 1 as issues in data set, right? Because this notebook was about that. So you can run this notebook yourself and create this data set to visualize these issues yourself. Now, what next? Next is, now that you know the issues that can occur in datasets, you obviously understand that cleaning has to be done. So first thing is about handling the missing values. How would you handle missing values? Are you going to delete that entire row? Which row are you, by the way, going to delete? How do you identify which row has missing values? Are you going to replace the missing values with some number? Let's figure it out. So we will go back to the code, open a new Julia notebook, and here we are going to deal with with the missing values. What I wanted to do was I wanted to make this notebook a little bit cleaner by adding the title, but it's okay. Let's not spend time on that. Here I'll put the title as handling missing values in the dataset. Just and then run this. So this becomes like a cell. And now we are going to have code cells. So what should we have? Let's bring this data here. So data frame, and then we should have some missing elements, right? So let this be missing. Let Katie's name be missing. And let the salary of this person be missing. So you can run this to see that the data frame has 3 rows in which there are missing values, and remaining 3 rows are, I would say, fine. Right? So first row, second row, and fourth row. Now, how do we identify rows where values are missing? So this is the code for that. So there is a function find all of is missing, and we are passing the df there, right? And should we look at all the rows and all the columns? I guess so. So first of all, let me run this to see if there is any error. I'm sure there should be some error, and then we can fix it. Okay, so no method matching. Okay. We may have to define that we are looking for all the columns. So I'm not sure if we need to write like this. Or let's first identify whichever IDs are missing. So in this case, here what it's going to do is like from the data frame, irrespective of the rows, you look at the column ID, column named title ID. And then if we run this, hopefully, yes. So now this is the row index. So in the first row, ID is missing. What if we do something like perhaps, yeah, I guess this is how we have to name. What if we write like this? Is this going to identify function keys exist, but no method is defined for this combination? So first of all, let's write like this. Find all is missing df of 1, right? So this basically checks df of first row, comma, any column. So if we want to find for a particular column, for all rows, which row has a missing element, we can do like this. So here, find all is the function. Find all rows for which there is missing within data frame df, such that you are looking at all rows but only column 1. So here in the first row, in all rows and column 1, only for the first row there is a missing. All the other rows do not have any missing. If this is 2, if I run, the output will be 4, because here is the missing. And if it is instead of 2, if it is 4, then missing is at second row. So the output will be, if I run this, output should be 2. I just want to figure out if how do we mention multiple columns here. Can we mention like let's say 1 to 4, something like this? This syntax does not work. So let's fix this syntax. A better thing to do is actually passing a row into the find all function. So we are passing a row such that what we do is, for any row, is there missing, for any row is there, let me delete this, this is not correct. So is there any row for which there are missing features? Now this is also not fully correct, but let's run. Now what's happening is row is not defined. So row has to be defined such that it is from the individual rows in the data frame. So if we just say df, this will not work. Maybe what if you say if it is df of 1, then this also will not work. What if we say for all rows in first column? Now, no method to iterate. Yeah, so here there is no iteration happening. We can write each row. This is a function as well. Each row in df. Okay, so this is the right thing to do. So let's discuss what we just did. So we have find all function. Of course, we can find all of this simply by Googling or using Cloud or ChatGPT, but we just wanted to play with this a little bit. So find all is the function for finding every single rows for which something is missing. How do we do that? We first get each row as a loop from the df data frame, and each row, the row from each row is being passed into the function any, such that this function any is looking for is missing element. whether there is missing or not in every single row. So this is the syntax. I just try to explain it in English language as best possible, but this is how you can do it. So here you can find the missing elements, right? Now, going back to our Miro board, so we have to first identify the missing values. So that's what we did. We identified the missing value. So let me write here, add a new cell, identify the missing rows with missing values. This we can convert to markdown, run, and run. Okay, so we just identified. So this step is done. First step is done. Okay. Now dropping rows or columns with missing values. So dropping means you are completely removing that. So let's see how to do that. There are a couple of ways to do that. So for example, our data frame is df. We can define another data frame called cleaned data frame, underscore df equal to df of which rows. So this is the index, right? So this find all, we can define this to be missing index. So index of the rows, meaning or missing rows, I would say. So missing rows in which something is missing are 1, 2, 4. So let's say I want to drop 1, 2, 4. I don't want these rows, and then all we need to do is df of these rows, not of these rows. So we want not of these rows, and we want all the columns. So I hope this is the syntax. Let's check if something is not correct. How about this? Not of missing rows is not working. We need every single column. So how about this? Okay, so this is working. By that logic, if we define, let's write one more line of code. If instead of this find all, is missing of df. Anyways, I don't think we should do this. Let's go back. I was just trying to simplify this syntax basically, but I guess not needed. So here what we are doing is we have, so this not of missing means, so here it is 1, 2, 4. What is not of that? We can just print it to see. Not will be 3, 5, 6, because we have 6 rows, and not of that will be those. We can see that by printing that. Inverted 1, 2, 4. Oh, what happened? Not of missing rows. Why is not of missing rows printed like this? What about missing rows? 1, 2, 4. df of missing rows. So I guess it's not simply 3, 5, 6. It is, so these are the missing rows, right? Now if we print ln missing rows, basically it converted into a row. Why is that? Okay, so inverted index. So okay, so inverted index 1, 2, 4. So we have missing rows, just one row, but if we print not missing row, there is this inverted index. So I guess automatically it figures out that the inverted index is everything but this. This basically tells that, I guess, to the data frame. Anyways, this is one of the ways in which you can drop the missing rows. So let me delete this because this is not needed. So here itself, we drop the missing rows. There is one more function which does the exact same thing. It is simply drop missing of df. So then this also drops. But if you simply try to print df, it will have those missing rows with missing value. See, missing, missing, and missing. So you can use this drop missing function. this can be assigned into a new data frame as well, which means if you print df2, it will not have those missing rows in which there are missing features. So this is one way to do this thing, which is dropping rows or columns with missing values. We can drop columns also. Let's see how to do that. Currently, we have been dropping rows. So let's say df2 equal to drop df of there is actually a select function in which you can select certain so here the select function, what it does is from the data frame, it's selecting second and fourth column. But we want those columns where these missing values are there, right? We want to remove the columns where missing values are there rather than columns 2 and 4. So here what it did is it selected column number 2, which was 1 to name. Column number 4 was income, so name and income are there. ID and age are dropped, but we don't know which all columns have missing. So here, in fact, except the age column, all other columns have missing features. So you want to drop all the columns with missing features. In reality, you don't have to drop entire column because your data set is aligned along the row. One row is one person. So you won't, just because one person has a missing age, you won't completely remove the age as a feature itself. So this is not practically done, but we can just do it here. So we can copy this and paste it here. So this is find all of row, right? So for each column, this is also a function. We pass column such that is anything missing in this column. Then if we run this, what else is missing now? Select df. Yeah, so what is missing here is we are selecting, okay, I think one bracket is missing. Okay, so here we are finding the columns in which there is missing, and we are selectively retaining only those columns where something is missing, but we want the opposite of that. So put not of this. Not of this means it should hopefully select only age. Yeah, exactly. So this is how you can drop a row where something is missing, right? So we saw how to drop a row. We also saw how to drop columns where there are missing values. Now let's get into imputation. Imputation is nothing but you are, instead of dropping a row or a column, you are replacing it with certain value. So to give an example, let's go to our notebook. Here in the original data frame, for example, here the ID is missing. We can replace the missing ID with some mean value. So if the mean value of these numbers are something, we can do that. Here also in the income, if this number is missing, we can replace with a mean value. Name, it's hard to replace with a mean value because for string, there is no mean value. But let's come to that. So here we finished identify rows with missing values. Then we drop rows with missing values, rows and columns with missing values. So let me add like a row, a cell at the bottom. So drop rows and columns with missing values. This is a markdown file. So convert to markdown and just run this. Okay. Now, what is next? Next is I'll put a markdown here, data imputation, which is not removing a cell, removing a row, but rather replacing with mean values. So for that, there is a function called coalesce. Coalesce dot of df dot, let's say the value that is missing is ID, right? For example, df dot ID such that find mean value of the ID of df dot ID. But how do you want to find the mean value? We want to skip missing. If something is missing, that won't be used for calculating the mean value. And coalesce and assign this to df itself, right? I hope. Let's run this and see. Mean is not defined in main, which means we have to use statistics. How about this? All right. Okay, excellent. So this worked. So basically, this coalesce, what it does is here it calculated the mean of 2, 3, 4, 5, 6. So you know that the mean of that these five numbers is 4. So the first missing value in ID, this guy was missing. Oh, actually, I should have simply let me run this once again, and here I'll put df imputed 1. Maybe I'll run like this. So now I just wanted to print df, and then I also wanted to print df imputed 1. So here the df imputed 1 means it's just printing the first row. So the id first column id, it's the first value was missing. The average of next remaining numbers is 4. So the first missing number is replaced by 4. That's what is happening. So this is an example of replacing a value with mean value. How about and let's do the same thing for income also, right? So now df imputed 2 equal to, we need to coalesce. Actually, let's just keep it as 1. We are coalescing now, not df.id. Let's do it on this itself. Df imputed 1, we find instead of id, we find income. And we are skipping the missing one, and we are finding the mean of the income. So we paste it here and we assign it back into df imputed 1. So let's run this. Array has no field called income because why is that? Df imputed Oh, I guess this is only 6. Okay, this is just the vector. Okay, fine. So which means df dot id equal to this. So I guess we have to first assign df imputed equal to df, then df imputed 1 dot id equal to, how about this? Then we will print df imputed 1. So now it should print s. This is printing the data frame. The first element is replaced by 4. Similarly, here df imputed 1 dot income. Now df imputed 1 should have an income. It is getting replaced by the mean value of income. So now if we run this, it is printing the df imputed 1 dot income, but we want to print df imputed itself to see if income has been replaced by the average value. So see, Brian's income was missing, but now it has been added. But now one more thing is missing, which is the name. Now what we can do is name we can replace with, let's say, unknown, some word like unknown. So then df imputed dot name equal to coalesce df imputed 1 dot name. And instead of mean, we calculate what we are going to do is, how about this? What does this do? Right. Now it converted the unknown, the missing part into unknown. Instead of missing, now it's a string called unknown. So unknown. Very good. Excellent. So now this is called data imputation. So in this part, what you studied is you learned how to identify the exact rows or exact columns in which there are missing data. And you also learned how to completely drop those rows or columns. You also learned how to replace those missing elements alone with some data, either the mean value of the entire data set or with some other constant. So here we replace with a constant called unknown. So this is data imputation. Now let's do data transformation, where we will be doing column transformation and we'll also create new features. But before that, let us save this notebook. I will rename this as data handling or data cleaning, maybe. Yeah. Okay, now let's open a new Python notebook. Sorry, a Julia notebook, not Python. And let's bring this data set here. But before that, what should be the title of this? We are trying to do basically data transformation. So data transformations, and run this as a markdown file. Then we run this. Now we have a bunch of missing values. After running this, you should have missing values, right? But then we have to add some columns or transform some columns. So what we could do in this is, let's say, rename this income. We can rename to annual income, assuming this is an annual income of the person. So let's do that first. The function for that is rename df such that income is renamed to annual income. I don't know if double quotes are needed. We'll figure out if it's needed or not. Income is not defined in main. Oh yes, not double quotes. To identify column by its header, you have to add this colon. So now, yes, now the header changed from income to annual income. So this is the way in which you transform the header of a column, so that here in the transformation, I simply meant that only. I did not mean anything fancy or complicated. We can also, by the way, create new features. There are many easy ways to do that. So let's see one of the ways to do that. So before that, let us identify type of df.id. What is this? Is this vector of int64, right? Now let's convert this into string, because id has missing numbers also. So df.id equal to string.df.id. This should convert the df.id into a string. See, missing became a string now. So now if we print df, what you should see is this is now a string. Previously, it should show int64, right? But I guess the question mark is there because there is a missing number, missing value. Here also question mark because there is missing. Here also question mark because missing is there. But here there is no question mark because age is complete. There is nothing missing. Okay. So let's delete this. So we converted df.id into string. So what we first did is we converted the title of or header of the column from income to annual income. Here we converted df.id into a string. Previously it was int64. Now let's do one more thing. Let's create a new column. So df, let's say the column name is called savings. Such a column does not exist, but let's say the savings are 30% of the annual income. So equal to 0.3 times df dot annual income. Is this correct? Let's see if this will work. Okay, df of column is not supported. Then we should do this. All right. So what we did is we calculated 0.3 times. Now let's print df. It should have one more. Okay, excellent. So now here what we did is we added one more column called savings, and we defined that people typically save 30% of their annual income, and that goes into savings. So 30% of 60,000 is 18,000, 30% of 120,000 is 36,000. 30% of this, but 30% of missing is missing. If income is missing, your savings are also missing. So that is this is how you add a new column. Now let's see how to add a new row. So new row is fairly straightforward. So let's add a new cell. Now let's try to push some value into df. So the value could be something like this. ID is now a string. So let's say the ID is 7 because we already have 6 people. Let's say name is Sylvia. Then what else? Age is 24. Income is, let's say, $50,000. And last is annual income. Annual income is, let's say, $15,000. Let's see if this push works. Indeed, the push worked. Now the Sylvia is added. So this is a new row, new data point. So here we discussed column transformation, creating new feature, meaning adding new column, right? And in this particular example, what was the feature that we added? We added savings. And then we also added new rows. So this is data transformation. And in data transformation, what we did, what all things did we do? We defined a data frame where some things were missing. We renamed the column from income to annual income. We redefined the type of the ID from integer to string. Then we inserted or created a new feature called savings and defined that as 0.3 times that of annual income. And we also added a new data point, which is a row. So now this is good enough for renaming the new file as what we did is data transformation, right? That's what we did here, data transformation. So I'll keep the same heading. All right. Now let's go into the last part, which is feature scaling. Feature scaling is exceptionally important in machine learning. I'm sure you will come across this when you are learning about, you have two features that define a particular data set. So for example, let's say it's about household pricing, right? So let's say this axis is number of bedrooms, and let's say this axis is square feet area. Now, there are two ways in which we can plot this. In one case, let's say number of bedroom is between 1, 2, 3, 4, 5, 6. 1 to 6, and square feet is 1,000 square feet, 2,000, 3,000, 4,000, right? So this is 1K, 2K, 3K, and 4K. Now, let's say the range of values are between here 1 to 6 and here 1,000 to 4,000. If we plot the data sets, right, it will be something like this. Let me just put some dots. These are some dots. So data sets can look something like this, right? And then we can probably say that all the data set that belong to this are houses whose price is greater than, let's say, 500K. So let's say this is houses with price greater than 500K, all these colors, and these are all less than 500K. And this is the line that separates them. Now here the separation is very obvious because the effect is very clear. But now, and the effect of bedroom is also very clear. There is some slope here. So if a house has, let's say some houses have something like this, if there are more number of bedrooms, it doesn't matter if there are more bedrooms, because as long as the houses do not have enough square feet area, then the houses are not very expensive. So all these in this blue color are expensive houses. I should change the color. Yeah, all these are expensive houses. The one in blue, all green ones are not so expensive houses. But now let's say we did not scale the data. So I'll show an example where now imagine that the scale of the axis is such that now I'll delete this. So here, what is the x-axis actually? It is square feet times 10 to the minus 10 to the 3, 10 raised to the 3. So here it's 10 raised to 3, because you can't put k like this on the axis. It's numbers. So here it's 1, 2, 3, 4 in square feet times 10 to the 3. So this is 1,000, this is 2,000, 3,000, 4,000. What if we did not do this? What if we simply did 1,000, then 2,000, 3,000, and 4,000? Then this axis actually, if the scaling was correct, then this is 1,000, right? This is 2,000. This is 3,000, etc. Right? Now, what should happen? Because the number of bedrooms is anyway between 1 to 6 only. So what we have to do is we have to scale this down. How does that happen? This scaling down happens like this. All of this will be squished into something like this. Then what happens is it's very difficult for us to create a classification for these data points. Meaning, for this data set, it's very difficult to classify. For this part and for this part, it's fine. But here it becomes very difficult because they will overlap with each other. It's very, very difficult for a machine learning model if the features are not scaled to learn here. That's the reason why you have to do feature scaling to kind of standardize your data. So we look at the importance of scaling, which is what we just showed here. But let's implement the scaling in practice. Now let's open the notebook and let's start a new one, new Julia for data scaling. So this is a markdown. So let me run this. So this is a text. So first I'll paste the data frame and this is how the data set is. Now we need to do the scaling. So let's do that. So first there is something called min-max scaling. So min-max scaling. And here, if we look at what this is, we subtract the minimum value of income from all values of income. So df.income, we change in such a way that we subtract from df.income minus min of df.income, but then we normalize this by dividing by min minus max. So max of df.income. So what this does is this subtracts the minimum value. So minimum is 4,000. Then minimum minus maximum is 4,000. It's 80,000 and 74. Sorry, not 4,000, 40,000. So minimum is 40,000. Max is 80,000. So this will subtract 40,000 from everything and will divide it by another 40,000. So let's run this and see what happens. So then this should ideally become, okay, no method exists for min. Let's see. What about minimum, maximum, and minimum? df.income. Okay, one thing we have to do is we are subtracting a constant value from all numbers. So here dot minus dot divided by dot minus. What about this? Okay, got it. So we had to put this dot because we are subtracting a constant number, which is this minimum is a constant number, maximum is a constant number, minimum is a constant number. So we are subtracting that from every single values in this income column. So then the income becomes something like this. And then if we try to print df once again, you will see that income has been scaled according to its, so the minimum value has now become 0 and maximum value has become 1 because we are dividing by max minus min. So here the scaling occurs from 0 to 1. All right, so this is min max scaling. There is also one more scaling which we can do. We can subtract the mean value from every single element and then we can add, we can divide by the standard deviation. So here, let's define another data frame df1 and df1.income equal to, let me copy paste this here. It is df1.income minus, instead of min, it's mean of df1.income divided by standard deviation, std of df1.income. So this should divide df1.income. Mean is not defined. Is it because we have to use statistics? Yes, it was because statistics was missing. So now if we print df1, you see the income has been scaled according to mean value and standard deviation. So this subtracted the mean value of the income from all numbers, and it divided by the standard deviation. And this is called as z-score standardization. I can write it here, z-score standardization. So we discussed implementation of scaling and z-score standardization. So we did this, and we did this and we did this. So this was subtracting mean and dividing by standard deviation. Now, one more thing I missed to talk to you about was this issues in the data set. So in the data set, there could be an issue like this. Where is that? Yeah, this one. So let's say we have a data set like this. I can start a new notebook. So this previous untitled notebook, we will rename as data scaling, because that's what we did here. Now, this was one thing which I should have discussed in issues in dataset, but I want to show it here separately. This is about outliers. So I'll start a new notebook and rename this as outliers, removing, identify and remove outliers. So what is an outlier? In this dataset, you can see that age, one person has an age of 1000 years. That is an outlier. So here we have to using data frames. So this is an outlier. Now, how do we identify this? And what is the basis with which we will remove these outliers? Let's see that. So there is a function called quantile. Quantile of df. From the df, we are taking all rows, but only the column with age. So let's say we are specifically looking at age, and what that means is we have to write like this, and 0.25. So what this means is quantile. I think for this we have to use the statistics package. So maybe we can write it here, because if we did not use this, it should throw an error. Maybe it's not throwing an error for me because I have ran the code with statistics once. Anyways, so we have quantile function from this module. So what it is doing is it is identifying all the data, or rather, it is the value below which 25% of the data lies. So here, if you look at this, 28. So there are 6 rows. So 25% is 1/4 of 6, which is 1.5. So maybe it's better if I remove this into like last 2 I can remove, because then 25% percentile is very well defined, right? So this is the df, and then here, okay, excellent. So now what we have is the number below which 25% of the data lies. What is 25% of 4? Because there are 4 data points. 25% is 1. So the number below which, so below 37, this one lies. Now, how did we come up with 37 instead of, let's say, 29? Because this 28 is below 29. That's because of the numbers over here. And then we can say Q25. So this is the data point below which 25% of the data lies. Then we can say Q75 equal to quantile of 0.75. So we define Q25 and Q75. And Q75 is that number above which 25% of the data lies. So below Q25, whatever the number is, this was 37.5, corresponding to this. 25% of the data lies, which is this data point essentially. And above this number, 292.1, there is 25% of data lying above this, which is this number. Now what we do is we eliminate those outside of this. Now here what's going to happen, not exactly outside of this, by the way. Let's there is another logic to it. There is the range of this quartile, which is Q75 minus Q25, and so now this is the range, and then we subtract Q25 equal to Q25 minus or let's say lower bound, lower equal to Q25 minus 1.5 times IQR, and upper bound is Q75 plus 1.5 times IQR. So here we are defining the threshold. Any data point below this and above this will be removed from the data set. So now what are we supposed to do? From the data frame dot age, not data frame dot age, df equal to df where for any row, or rather df, we want age to be less than this and greater than this. We can use find all function for that. So here we are passing x, where x is belonging to this. Here we are passing any row but the column age, where it's taking row by row, such that the value of the row in this column should be less than lower or greater than upper, because these, if either of these conditions are satisfied, we have to remove them, right? So first let us run this. If we run this, you should get 4. Yeah, because this guy is outside the bound. Now we have to remove this from the data frame. For that, it's very easy. Df equal to df of, not of this. If we say remove indices, so these are the indices of the data points that we need to remove. Just put it like this. If there is any error, that's probably because we are not mentioning that we are picking all the columns. Okay. So see, now the fourth data point is removed. So basically here we found the outlier based on the age, because in the age there was an outlier. This is because we could see that there was an outlier. What if we did not see? How did I select only the age column? We cannot do that. We have to select ID, age, and income. Whichever columns have numbers, we have to find the outlier. Sometimes the name, what if the name is something weird? We have to figure out a way to describe the outlier. But for numbers, the outlier is simply much higher than what you normally see, or much lower than what you normally see. So here we defined this IQR. IQR is nothing but interquartile range. The range between bottom quartile, the 25 number below which 25% of the data belongs, number above which 25% of the data belong, the range between those two quartiles, that is interquartile range. And here we are defining the lower bottom Q25 minus 1.5 times IQR as the lower bound, and Q75 plus 1.5 times IQR as the upper bound. So then upper bound becomes 676. Any number above 676 will be removed from this data set. So with this, let's come to a conclusion in this lecture. I know that this was a little bit longer lecture. I wanted it to be a bit shorter, but then while recording, I realized that if I try to make it shorter in terms of time, I will have to go a lot more faster, and I won't be able to talk about these many things. But I also enjoyed a lot while creating this lecture. This hopefully brings a lot of clarity into you about various things that you are supposed to do when you are dealing with data science. In machine learning, before you even teach a machine learning model to learn the patterns in the data, you have to clean up the data. You have to make sure that the data is something that a ML model can use. Otherwise, it may learn the wrong thing. Otherwise, it may fail to train altogether. So this lecture was a perfect kind of an example for what all things you have to learn when it comes to basics of data science before you even enter into machine learning. So with that, let's come to a conclusion to this lecture. And I want to appreciate you for going through this whole lecture and also through this whole series. In the next lectures, we will deal with few more things in data science, such as data visualization, and a few more slightly more advanced topics. After that, we will be formally entering into machine learning. So thank you so much. Stay with me. We are laying the foundation one by one for data science and machine learning in Julia. So you are learning Julia, you are learning a bit of data science, machine learning, as well as deep learning at the end of the course. So let's lay one brick at a time, one lecture at a time. Let's go. So hopefully you are enjoying. We'll see you again in the next lecture. Thank you so much. Take care. Bye.